Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna continue exploring the new nodes called color in and color out in Sverchok. I like those nodes a lot because it's allowing you to use the HSV color mode to colorize objects. So let's just get started. Instead of generating objects, this time I will use just a mesh. It's like a single object and then multiple polygon face and then colorize the face. So that's gonna be a lot faster. Yes, so let's switch to cycles render. Let's save this real quick. Color in exploration, color in and color out. This is the node we're gonna use. I'm gonna create a plane, and this should be generating a mesh, our mesh. Let's use the B-mesh viewer and output the mesh right away. So this guy currently has few vertices. I'll quickly create a material for it. And this is a cycles render material, so we're gonna colorize the polygon face using vertex color nodes. So this is our output, this is our object, and we're gonna colorize the face. And as soon as we did that, we should get the SVG call. And if we select our object and look at the data, we already have the SVG call for the color. So if we switch to the material and check this out, and we use the attribute for this guy specifying SVG call, we should get our color. So I did this a couple of times already in the past, and previously I only using like random vector to generate the color of the face, so something like that. So 2 by 2 vertices actually only create a single face. Maybe we need to have more. Obviously. Okay, now we have some kind of playground to work with. File, save as, version 2, and we don't need to see this this guy anymore. We can hide it. Back to Sverchok. For the vertices, let's see, let's make this 20 by 20, so we have 400. And yeah, let's just get started with this color in nodes. I believe the vertex color actually doesn't care about alpha, so we can just plug in this color in with the alpha off. So it's not RGBA, this is more like RGB, so we can easily just plug that in. Really, previously we are able to use this to create random color, but the random color is too random. I actually like this a lot because if you plug this guy in and switch to HSV and then wait until I did something, currently it's all black. I think if I switch it on, so yeah, it's already working. This is like 400 polygon face, if I'm not wrong. Actually, this is 400 vertices, but 361 faces. So more like 361 faces. And I should be able to control each and every face color. You see, that's really fast. And so let's somehow use the hue to control the color, the hue, and that should go based on anything. Actually, I'll start with the index. Actually, the index, we can use a range integer. We know that we have 361 faces, so the integer should go from 1, start from 0 and end up with 360. So this value, if we check it out, goes from 0 all the way to 359. Maybe we should go up a little bit, 360, maybe even further, 362. And we have this number, and we need to divide this number using the total number. I believe we just use math and division. So this number divided by, let's just make it like 360 and then plug this into the hue. Hopefully we get something. There you go. There you go. That's exactly what I was expecting. Is that's the magic. And then we can actually play around with this number. And apparently the vertex color new actually have some kind of looping. So that's nice that we are getting this repeat automatically. So this is really cool, right? Surprisingly, you get like a rainbow color. That's because of we are using the hue, and the hue, when it goes around, it goes in a rainbow color. So red, you know, orange, yellow, green, and so on until it goes back to red. So this is the first trick that we'll learn. You can also play around with the saturation and value, and with this. Let me have a think first. It gets a little bit tricky, but this is just like if you are procedurally generating texture using the OSL, open shading language. This is kind of a similar idea. So, but instead of using like a list, normally you'll start to use like a 2D space or even like a 3D space. Let's say like you have an objects in the 3D scenes and kind of measuring the distance. You can easily actually colorize and generate texture procedurally using that kind of method. So based on, it's always like you're referencing one thing over another. Let's say instead of the rainbow color, we can use the modulo. Maybe we can use like a sine wave. So this is if we are using the rainbow color, so we can cut this. So we should get this color for now, and then let's say if I'm using the list and using sine wave function, I should be getting some kind of gradient. So sine wave, so depending on the count, so this sine wave, we can control the frequency and things like that. Kind of like a stripes of color, maybe over here. So that's with the sine wave. Not particularly super interesting, but still it's something. And then we can also use the vector. Obviously we already have a cool node that does that, vector fractal and vector noise, especially interesting. This vector fractal requires vector position, so we can easily do that using the center polygons. So yeah, let's get the center polygons from this guy, and based on these informations we can plug that into the vertices of vector fractal, and the output should be like a scalar value, scalar floating value that we can use for the color. Actually in this case either the hue, or let's plug into the hue and have a look. So there you go. This is a fractal based on the vector position, and also it's generating this kind of rainbow color. I'll reduce the saturation maybe a little bit so we get less saturated design. We play around with this value, and at some point we should be getting some kind of pattern. It's easier to see this actually with black and white. So I don't know, HSL, I hardly use HSL actually. So this is hue. HSL similar to HSV. Maybe plug this into the luminosity. So there you go. That's fractal value based on the position, center position of each polygon face. Looks like a pixel art at the moment. We can change it to other noise. Looks really abstract. I really like this. And you can of course control the vector using math like fractal, multiply scalar. You make it small enough and you can start to see a pattern that this guy is generating. Okay, this one, control the contrast. That's really interesting. Instead of scaling, you can also use another vector math and actually just use like move, for example, moving all the vector in certain directions. This should also control the noise, maybe in the z-axis. So this is normal, usually really interesting. You can always increase this further, like 40 by 40, 1600 pixel. So still pretty small. I'll go higher, you know, let's make it 10,000 pixels, 100 by 100. Okay, now we can see the pattern. This is something that you might be familiar with. It's a 3D it's a 2D kind of procedural pattern that you normally see if you are using cycles or procedural textures in Blender. So this Fractal, New Perlin, Blender, Voronoi. Whoops, Voronoi. That Voronoi doesn't give you anything. So at this point, it seems to get a bit slower, but still manageable. This is not too bad at all. Change the octave. I think the octave is like the detail. That's with the fractal. Actually, the hue doesn't change much. I'll reduce this just for our purpose. We don't need too much pixel. Just 2500 pixel is enough. You can also use vertex and loop, by the way, not face, but the face, I make it face because it's much easier. And you can control this hue as well. This is the saturation. Yeah, okay. You can have like unlimited number of variations this way. Yeah, I haven't experimented much with this setup. This is actually like an improvisation. So what else can we do here really? We can try plugging in whatever value here. You'll get a surprise sometimes. We can also use a vector noise. Vector noise can be interesting. If we use this guy, plug into this guy. So the center polygons position goes into vector noise. And plug this into the HSV or HSL value and let's see what we get. Oh, actually I just plug in a vector into this guy. Not a good idea, maybe scalar for now. So that's something that looks like a Perlin noise, but it's much more interesting because it's in our like our color like HSL. Again, we can use vector scalar and this become like a multiplier for the noise. And also the move and this vector to push our vector position. So the Z usually is interesting because this is all like all happening in 3D. So the texture is being generated on the fly in 3D. So this is pretty fast. It's pretty cool. HSV, HSL, we get a like spectrum of color. HSV also kind of doing similar thing. If I'm not wrong, we can also use lerp. We already tried it at some point. Lerp and the vector and the vertices color. Okay, let's try this. I think we should be getting some kind of gradation. Let's try red and green, for example. Maybe not lerp, but evaluate. Vector evaluate, and Sverchok should generate a value. Oh, vector evaluate is outputting a vector. So that's okay. That's not gonna work that way, but we need a scalar. I should remind myself that we need scalar, but we can also use vector out from this guy and use it like this. Okay, that doesn't really do much with the color. Maybe I should do some kind of mixing of color. Well, yeah, that's interesting, but it's a bit random, unpredictable. Brilliant. Let's try cell noise. So that's it's also really interesting. So we know that we can use the vector position, and we can also mix this guy. So we have control over color from the noise, and we have color out here. And if I'm not wrong, we can really just mix this together. So this is color out. So we can separate the color. Let's see, and then we can combine it again. So we can have this and this. So if we color out this guy and just get the red value, plug into this RGB. So in a way, this is like separating the RGB. Interesting. It's almost like the image compositing editor in Blender. You can mix the RG, like switching the value and get a different result. Let's see, I'm trying to think what else we can do here. Color in, color out. Maybe we can mix our own color. Let's bring in our own color so we can control this. We can hopefully at some point we get like a color mixer, but we don't have, I don't think we have color mixer yet. But we can always use math, and because this guy's RGB, I wonder if this actually works. Oh yeah, this actually works. So you can just use this color in, color out. So RGB, and then mixing this value. Oh, maybe adds. It's complaining about something, exception. Maybe that's not how we should do it. Well, I'll have a think on that and try again at some other point, but I guess that's pretty much it for this. So it gets pretty random, but it's basically, I don't know, I think that there's something with HSV that you can really use, because it's displaying color in such a way, you know, that it goes in the brightness, the hue controlling the the rainbow color spectrum, and then the saturations controlling saturation and desaturation, and the V controlling the value like brightness. Maybe we can try something with the brightness next time. For now, I guess we can leave it right here. Yeah, so that's it for this live noding. If you have any questions, suggestion, feedback, just let me know. I'll give you this node setup as a gist again. Just export to gist, and I guess I'll see you in the next video. Thanks again for tuning in. Yeah, and don't forget, if you have any question, just